Hi guys, we're going to go over lesson 8.3, solving systems of equation by substitution. If you look at your lesson objective, it says to solve systems of linear equations by substitution. And the word problem says that Nadia has a rectangular picture frame she wants to decorate. She knows the perimeter is 56 inches and the width is 6 inches longer than the length. What is the area enclosed by the picture frame? So we're looking for the area that is enclosed by the picture frame. We're going to solve by substitution, and it says graphing a system of equations may not always be the best approach to finding the solution. Another way to solve a system of equations uses an algebraic technique called substitution. So what is the area enclosed by Nadia's picture frame? Well, let's let H represent the height of the frame and W represent the width of the frame. So the perimeter is 2H plus 2W, which is equal to 56. The width is the height plus 6, or W, the width, is equal to the height, H, plus 6. And we're going to solve the system of equations by substitution. So we're going to substitute H plus 6 for W, because we found out that W was equal to H plus 6 in the first equation, and then we're going to solve for H. So therefore we get 2H plus 2 times H plus 6, because we're putting that in the place of W, is equal to 56. 2H plus 2H plus 12 is equal to 56 because they multiplied out the 2 and they did 2 times H and got 2H, and 2 times 6 is 12. Now, next, you're going to add the two H variables together. So 2H plus 2H is 4H. Okay? And you have to subtract 12 from both sides. And they skipped that step. They didn't show you that step, but I want you to know that's what they did. So they got 4H is equal to 44, because 56 minus 12 is 44. And then they divided by 4 on both sides. So they got H is equal to 11, because 44 divided by 4 is 11. Turn the page to page 458. And it says substitute 11 for H in the equation W equals H plus 6 and solve for W. So W equals 11 plus 6, we know that, which is equal to 17. Now, then you can go back once you have your solution, which we figured out our solution is 11, 17. And in each of the original equations, you can put in those numbers, and you can check to make sure that your work is correct. The height of the frame is 11 inches, and the width is 17 inches. Thus, the area enclosed by the frame is 11 times 17, because you know the area is equal to height times width. And that is 11 times 17 is equal to 187, or 187 square inches. The first step in solving a system of equations by substitution is to isolate one of the variables in one of the equations. You can always solve the system regardless of which variable you choose to isolate, but sometimes one of the variables is easier to isolate than the other. So we're going to do the ongoing assessment together here, and the first, they gave us two equations, 3x minus y equals 1 and 2x plus y equals 9, and we're going to solve the system of equation using substitution. So the first thing I'm going to do is solve this equation over here for y. Okay, we're going to solve this one. Alright, so I'm going to subtract 2x from both sides. And you get y is equal to negative 2x plus 9. Alright. Now, I'm going to go back to this equation, and I'm going to put in negative 2x plus 9 for the y. So, you're going to have 3x minus 1, because remember, there's an understood 1 right there, times negative 2x, and that's important to remember because it'll make your problem wrong if you don't remember to put the minus 1 there, plus 9, and I just got that from here. I just put in negative 2x plus 9 instead of the y, is equal to 1. Okay, and then 3x Okay, and then we got to figure this out. We got to multiply this 1 into these two numbers. So -1 times -2 is +2. So 3x plus 2x. Okay, and then -1 times 9 is -9. 3x plus 2x minus 9 is equal to 1. And then we have to add our x variables together. So 3x plus 2x, of course, is 5x. And then minus 9 is equal to 1. And then we have to add 9 to both sides. Okay, and we get 5x is equal to 10. Oops, I forgot the x. Y'all have to tell me, but you're not here, so you can't. Okay, and then you divide, of course, by 5 on both sides, so we can get x by itself. And you get that x for the solution for this system of equations is going to be equal to 2. All right, so we can go up here for our solution, and we can go ahead and write our x in because we know it now. It's going to be 2. Okay? And actually, I'm going to go ahead and erase all this, but then I'll draw this part back again, okay? So that's how you do the first part. You solve for one of the factors by substitution. You use one problem and solve for a variable like y, and then you substitute it into the other problem and you find what the other variable is, x. Okay? So your x is equal to 2. Now let's erase this. Okay, and we're going to write in that we know that our x is equal to 2 now because we did that work. Alright, now let's figure out what y is equal to. And I didn't like this problem because it has fractions, I'm just warning you, but we're going to do it anyway. Okay, so we're going to solve this equation for x. Okay, so we're going to add y to both sides, plus y, and we get 3x is equal to y plus 1. And then we've got to divide by 3 on both sides. Okay. And we get that x is equal to 1/3 y plus 1/3. Okay? Then you take this equation over here, and everywhere you see x, which is one place right here, you're going to put in 1/3 y plus 1/3 because we found out that x is equal to 1/3 y plus 1/3. So we have therefore 2 times 1/3 y plus 1/3 plus y equals 9. Okay? So then we multiply this into these and we get 2/3 y plus 2/3 plus y is equal to 9. Okay, and then we're going to add our y's together, so we get 1 2/3 y, because remember this y has a understood 1 with it, so we have to add that to the 2/3, so we get 1 2/3 y plus 2/3 equals 9. And then you have to subtract 2/3 from both sides.
And
you get 1 2/3 y is equal to 8 1/3. Okay? Then you divide both sides by 1 2/3 because you want to get y by itself. Okay, so and then you get y, 8 1/3 divided by 1 2/3 is actually 5. So y is equal to 5. Okay, so then your solution for this system of equations is 2, 5. And we use substitution to figure that out. Now we're going to practice this in class because I think we need more practice with it. Obviously, this is something that you're going to have to do some practice with to really understand it. So we're going to do activity 1 and activity 2. We're going to do both of those in class together with your group, and then we'll talk about them and really go through them. You can try them if you want to, based on what I just taught you here in this video. You can try them at home and see if you have any questions. And you might want to watch this video more than one time because I know that especially with the fractions, this could have been a little bit hard to understand. So you guys have a good night, and I'm going to go ahead and upload this video, and then I'll start lesson 8.4. All right, now we're going to look at lesson 8.4, and the objective for lesson 8.4 says to solve systems of linear equations by addition or subtraction. And so that's what we're going to be doing in this lesson. If you look at the word problem, it says Nancy and Jim are team leaders at a computer chip manufacturing company. The production supervisor needs to report the number of computer chips each team made on Friday. The supervisor knows the total number of chips produced by both teams is 130. Nancy's team made 10 more chips than Jim's team. How many computer chips did each team make? So first we're going to learn to solve by addition. Now, both the graphing and substitution methods can be used to solve systems of equations. However, you can also use another method based on an alternate form of the addition property of equality. And the addition property of equality alternate form that we're going to use is for all numbers a, b, c, and d, if a equals b and c equals d, then a plus c equals b plus d. So under that, it says this property allows you to form a new equation from two existing equations. For example, suppose you have the following system of equations, a equals b and c equals d. If you add the left sides and the right sides, a new equation results. A plus c equals b plus d. And as you can see, I have this here. I also wanted to show you in numbers how this works. So if you have 3 equals 3 and 2 equals 2, then you have 3 plus 2 equals 3 plus 2. And we know that's true, that those are equal. They are the same because they both equal 5. And 5 is the same or equal to 5. It's very important that you understand what an equal sign means. An equal sign does not mean the answer is. It means that both sides of the equal sign are the same as each other. They're equal. Okay? Now, I also did it with this. Negative 4 plus 1 is equal to negative 4 plus 1. And negative 2 is equal to negative 2. So then we come down here and we have negative 4 plus 1 plus a negative 2 is equal to negative 4 plus 1 plus a negative 2. And we know automatically that that's true because you're adding the same group of numbers on both sides. Okay? And negative 4 plus 1 is negative 3, plus negative 2 is negative 3 plus negative 2 is negative 5. Okay, and we know that negative 5 is equal to negative 5. So as you can see, now you can see a little bit better how this works when we actually use numbers here. Now the reason for using the addition property of equality to form a new equation is that in certain cases the new equation will contain variables that are opposites. Because opposites sum to 0, the new equation will contain only one variable which you can solve using the methods you previously learned. Let's look at example 1, solving by addition. Reread the opening paragraph of the lesson. So let's go ahead and do that first. Turn back to page 463 and let's read that. It says Nancy and Jim are team leaders at a computer chip manufacturing company. The production supervisor needs to report the number of computer chips each team made on Friday. The supervisor knows the total number of chips produced by both teams is 130. Nancy's team made 10 more chips than Jim's team. How many computer chips did each team make? Okay, now how many and we turn back to page 464, sorry. It says how many computer chips did Nancy's team and Jim's team make? And let's look at the solution. Let X represent the number of chips made by Nancy's team and let Y represent the number of chips made by Jim's team. The following system models the information known by the supervisor. We know that there were 130 total is the total number of chips, 130 by both teams. Both teams made a total of 130 chips. So we know that X, which is the number made by Nancy's team, plus Y, the number made by Jim's team, equals 130, the total number made. Now, and we also know that X minus Y equals 10 because it says that Nancy's team made 10 more chips than Jim's team. So Nancy's team's number minus Jim's team's number is equal to 10. Use the addition property of equality to add both sides of the equation. And they did that there for you. X plus Y plus X minus Y equals 130 plus 10. Okay? Notice that Y and negative Y are opposites and their sum is 0. Thus, the Y variable is eliminated, leaving an equation with only the single variable X. X plus 0 equals 130 plus 10. Okay? And then they added the two X's together, so they got 2X. And they also added, then they took the 0 out because you don't have to add nothing to that. Okay, and so 2X, and then 130 plus 10, of course, is 140. Then they divided by 2 on both sides to get X by itself, and 140 divided by 2 is 70. So they got X is equal to 70. Substituting this value for X in either of the original equations results in Y equals 60. The ordered pair 70-60 is the solution for the system of equations. Nancy's team made 70 computer chips, and Jim's team made 60 computer chips on Friday. So as you can see there, they substituted the X equals 70. They found out that X is the same as 70. So they went back up to their original equations and they put in 70 for X, which I would probably, it doesn't matter which one you would use. You put 70 in for X and you either subtract and then you solve for Y in either of those equations and you will come up with 60. And you can plug it back in and see. As you know, 70 plus 60 is 130 and 70 minus 60 is 10. So it both works and checks for both, okay? So now we're going to do the ongoing assessment together. It says solve this system of equations using the alternate form of the addition property of equality. So what you're going to do is you're going to add both sides together, okay? And so what you're going to get is X plus Y, and that needs to be in parentheses. Oops. Okay. X plus Y plus X minus y is equal to 100 plus 20. Okay. Now, as you can see, positive x and negative x are opposites of each other, and so they cancel each other out. Positive y and negative y, excuse me, are opposites of each other, and they cancel each other out. So we can get rid of them, okay? And we get x plus x. And in the previous problem, they put plus 0 to show that when you add y plus negative y, you get 0. But I'm going to leave out that part. You'll just essentially have x plus x. And I think you guys understand that. And that is equal to 100 plus 20, which we know is 100 and 120. Okay, so then you get 2x, you add the two x's together, and you get 2x is equal to 120. And then you divide by 2 on both sides. Ooh, excuse me. Divide by 2 on both sides here. And you get that x is equal to 60. So for your solution for this system of equations, your x number is going to be 60. But now you need to take 60 and plug it into one of these equations here, okay? And I'll just plug it into the first one, 60 plus y equals 100. Okay, and then of course you subtract 60 from both sides because you want to get y by itself, minus 60, and so y for your solution is going to be equal to 40 because 100 minus 60 is 40. And I know that looks like an H. Let me fix it. Okay, let's try to make that better. So y is equal to 40, and then you go up here and you put for your solution that for this system of equations, the solution is 60, 40. All right, now we're going to look at the subtraction property of equality. On page 464 at the bottom, it says you can also use an alternative form of the subtraction property of equality to solve the systems of linear equations. So the alternate form of the subtraction property of equality that we're going to use is that for all numbers a, b, c, and d, if a equals b and c equals d, then a minus c equals b minus d. So it's the same principle as the addition property of equality that we used before, but this time we're using subtraction. Let's look at example 2. Subtraction can also solve the computer chip production system of equations. X plus y equals 130, x minus y equals 10. Okay, that's what we had in the other example. This time, subtract the expressions on each side of the equal signs. Notice in the following steps how the x variable is eliminated. So when you do that, you have x plus y equals 130 and negative x minus y, the opposite of, or the negative of, x minus y equals negative 10. And then you use the subtraction property of equality, and you have x plus y minus x. X plus y equals 130, and negative x plus y equals negative 10. Then you have 2y is equal to 120 because x minus x is 0. So they just add, and then they added the two y's, and they got 2y is equal to negative 120. 2y is equal to 120, and then y is equal to 60. The result of replacing y with 60 in either original equation gives x equals 70. Now, example 3. Solve this system of equations: 2x plus 2y equals 10, and 3x plus 2y equals 14. Use the alternate form of the subtraction property of equality to subtract the expressions on the left side and the expressions on the right side of the equation. 2x plus 2y equals 10, and the negative of 3x plus 2y equals negative 14. So when you do that, you have 2x minus 3x, which is negative x, and then 2y minus 2y, which is 0y, equals negative 4. And so you have negative x equals negative 4, so x equals 4. To solve for y, substitute 4 for x in the first equation. 2 times 4 equals 2y, plus 2y equals 10. 2 times 4 is 8, so 8 plus 2y equals 10, and then 2y equals 2. Divide by 2 on both sides, and you get y is equal to 1. So the solution to the system of equations is 4, 1. And you're going to check the solution in both equations. Now, honestly, they changed up the way that they showed you this for the subtraction property of equality and the way they wrote it out for you on page 465 in these examples. I don't know why they did that, because it makes it look more difficult to you that way, I think. But that's okay. I'm going to show you how this looks just like when we did the addition property of equality. Okay? So we're going to do the ongoing assessment together. You're going to use the alternative form of the subtraction property of equality to solve the following system of equations. So simply put, all we're going to do is we're going to take both sides of this equation and we're going to subtract them. So we have 2x plus y minus 2x plus 3y. That's a 3. Okay. Is equal to negative 2 minus 0. All right. So now what we have here is 2x plus y, and we have to distribute this negative throughout these parentheses, so we get minus 2x minus 3y is equal to, we already know that negative 2 minus 0 is negative 2. Okay. Now, as you can see here, we have a positive 2x, positive y, negative 2x, and a negative 3y. The positive 2x and the negative 2x cancel each other out. Okay, and so you're left with y minus, oh my, it's starting to mess up. A minus 3y. Y minus 3y is equal to negative 2. Okay, oh my goodness, I'm sorry you guys. It's just not working for me tonight. Okay, is equal to negative 2. And then y minus 3y. So that is 1 minus 3 is negative 2. So negative 2y is equal to negative 2. Okay. And so when you divide both sides by negative 2, you get y equals 1. Okay, so y equals 1. So you know for your solution, you can come up here and you can go ahead and start it. And you can put that 1 in there because you know y is going to be equal to 1. Then you go to your original equations and you put in 1 for y in either of the equations, and you get 2x plus 1 is equal to -2. Okay? And then we're going to solve for x, so we're going to subtract 1 from both sides. And we get 2x is equal to -2 minus 1 is -3. Okay? And so then x, because we have to divide by 2 on both sides, divided by 2, divided by 2, and so x is equal to -3/2. -3/2, or -3/2. Okay, and so then you come up here to your solution and you put in your x value for your solution to this system of equations. Okay, so the solution to this system of equations is -3/2, 1. Now, we're going to do the activity on page 466 in class so you can get practice with this. Write down any questions that you've had about this, and we will answer them tomorrow. Thanks, guys.